Black holes outselling pop stars. You better believe it. We're taking a deep dive into Stephen Hawking's A Brief History of Time.
It's amazing, isn't it? The power of the cosmos to capture our imaginations.
Hawking really had a way of making these mind-boggling ideas understandable, even fun. Speaking of which, remember that story, the one about the Earth bouncing on a tower of turtles?
Oh yeah, the turtles all the way down bit. Classic Hawking using humor to introduce some pretty deep concepts.
Right. And it gets you thinking about how for, forever, people have been trying to figure out the universe.
It's true. Humans can't resist a good cosmic mystery, and some of those early attempts to explain it, well, they definitely seem a bit, creative now.
Totally. Like Ptolemy, for instance. He was absolutely convinced that the Earth was the center of everything. He even worked heaven and hell into his model of the universe. Can you imagine?
It's wild to think about, right? But his ideas were a reflection of the time, a product of the prevailing beliefs.
Right. It was all about what they could observe and what made sense with their current understanding.
Exactly. And then Copernicus comes along and says, hold on a second, what if the sun's the center? And then Galileo backs him up using his telescope to gather evidence. Talk about shaking things up.
Total paradigm shift. I mean, we go from thinking the Earth is this, all-important center to just another planet orbiting the sun.
It really makes you realize how much our understanding of the world, the universe, can change when we're presented with new information. It's like, are we so sure of what we think we know?
It's a good question to ask yourself in any situation, really.
Absolutely. It's about challenging assumptions, being open to new perspectives. Just like Copernicus and Galileo challenged the accepted model of the universe, we too can benefit from questioning our own deeply held beliefs. Who knows what we might discover?
I like that. And speaking of challenging assumptions, let's talk about Einstein. Before him, time was this untouchable, constant thing, ticking away uniformly throughout the universe.
Yeah, and then Einstein comes along with his theory of relativity, and suddenly time is fluid, flexible even. It's affected by gravity, by motion.
It's like, imagine you're on a train, playing ping pong. To you, the ball's going straight up and down.
Hmm.
But someone watching from the platform sees a totally different path.
It's such a great way to visualize relativity. It highlights how our perception of time isn't absolute, it's influenced by our position and movement relative to other objects.
Mind-blowing, right? And this isn't just some abstract theory. It has real-world implications.
Oh, absolutely. I mean, GPS technology, it wouldn't work without accounting for the effects of relativity.
Whoa, that's wild. See, it's these hidden connections that make physics so fascinating. But it's not all wild theories and abstract ideas. Take the Michelson-Morley experiment, for instance.
Right, they were trying to prove the existence of the ether, this invisible medium that light supposedly traveled through. It was a popular theory at the time, really elegant and beautiful.
It makes sense, right? I mean, if sound needs air to travel, it seems logical that light would need some kind of medium, too.
Exactly, but here's the thing. Their experiment found absolutely no evidence of this ether,
Talk about a scientific reality check. But that's how science works.
right?
You test your assumptions, even the beautiful ones.
Precisely. It's about being open to the possibility of being wrong, no matter how elegant the theory. And sometimes letting go of those cherished ideas can lead to even more incredible discoveries.
Speaking of incredible discoveries, let's talk about Stephen Hawking's fascination with black holes. It's amazing how his early work on the Big Bang led him to these cosmic titans that are, well, essentially the opposite. It's like he was trying to unlock the universe's biggest secrets and stumbled upon something even more mind-blowing along the way. And here's the thing about black holes. They aren't just these isolated oddities hanging out in space. They're actually connected to us, to the entire cosmic story in ways you might not expect.
That's what's so cool about cosmology. It's not just about what's happening out there, but about understanding our place in this grand scheme of things. And yeah, black holes are a big part of that story.
Right. We talked about the Big Bang earlier, that incredible burst of energy that started it all. But here's something else to think about. Every time we look at the night sky, we're actually looking back in time.
Isn't that wild? Light travels unbelievably fast, but these distances are just, well, astronomical. So that light from a star millions of light years away, it's been traveling for millions of years to reach us. It's a real cosmic time capsule.
That is wild. So we're seeing these stars not as they are, but as they were millions of years ago. Okay, so we've gone from turtles to telescopes to time travel. Get ready for the next level because it's about to get even weirder when we talk about the quantum realm. Stick with us, though. It all ties back to you, I promise.
Quantum mechanics. It's where the universe throws out the rule book and says, good luck figuring this out.
Seriously.
Yeah.
Like the idea that particles, those tiny bits that make up everything, can also act like waves. And waves can act like particles. Wave-particle duality, they call it. It makes my head spin just trying to picture it.
It's definitely one of those things that's easier to describe mathematically than with, like, a mental picture. But here's the thing. This isn't just some abstract idea floating around in a physicist's brain. It has real-world applications.
Wait, really? You're telling me that something as weird as wave-particle duality powers this stuff I use every day?
Absolutely. Your phone, your computer, pretty much all modern electronics, they wouldn't exist without our understanding of quantum mechanics.
That's insane. It's like I'm holding a piece of the universe's greatest mysteries in my hand. Okay, so back to Hawking. One of the things that struck me about A Brief History of Time is that he doesn't act like he has it all figured out. In fact, he ends the book with a whole bunch of questions.
It's true, he does. And those aren't just any questions either. He's grappling with some of the biggest mysteries out there, like the beginning of the universe, the nature of time itself. He even gets into the anthropic principle, this idea that the universe seems almost tailor-made for us to exist.
Wait, hold on. So you're saying our existence, right here, right now, is somehow woven into the fabric of the cosmos? That's a pretty big concept.
It is, and there's no easy answer. But it makes you think, doesn't it? Think about it. All those fundamental forces, the laws of physics, everything had to be just right, or else, well, we wouldn't be here.
So are we just incredibly lucky?
Yeah.
Or is there something more to it? It really makes you feel kind of small, like our whole planet, our entire history, it all comes down to a cosmic coin toss.
In a way, yeah. But I think there's something kind of amazing about that, too. It's like, out of all the possibilities, here we are. But you're right. Hawking doesn't give us easy answers, does he? He leaves us with more questions, this sense of wonder. And that brings us to one of my favorite quotes from the book. God abhors a naked singularity.
I was hoping we'd get to that one. God abhors a naked singularity. It sounds more like something you'd hear from a poet, not a physicist. What does it even mean?
Well, a singularity, that's a point of, like, infinite density, the kind you'd find at the heart of a black hole.
Okay, got it. So what's naked about it?
It's the idea that a singularity could exist without an event horizon.